Hello and happy Sunday AI for Robotics class. I wanted to go over a few topics here, no pun intended. And number one is the Intel RealSense camera, and then we'll review the ROS, logging into the VAR instance that we created. It's like an ISO file in Ubuntu 16.04 Melodic. But let's go over the camera sensors first. What I want to show you guys here is the depth strain information. So you can kind of see this is what your robotic car is going to see. We're going to be pulling a lot of this information off via topics, and this is actually a node within the system that is publishing information to other subscribers. We'll go over that soon. But what I wanted to show you guys here is the accelerometer streams and gyroscope streams that we talked about, the X, Y, and Z. This information is being pulled off that 6-axis inertial measurement unit. So it understands where it is in space, the yaw, the pitch, and the roll, and all that information. But also the color stream information, the RGB, is going to be advantageous for us later as we start to integrate machine learning algorithms in TensorFlow 2.0 for navigation and planning. So it knows, all right, that's a red piece of paper, that's a blue piece of paper, that's a yellow piece of paper. I want to find the blue one. Keep going, keep moving on. We'll get into that later. So just this is a very quick overview of the depth camera information, but each one of these pixels has depth information in it, right? So it's positioned in space in accordance to a reference frame, x, y equals 0, 0. And then it would let you know, okay, this pixel in space or that color is going to be this far away and this is its position. And so that's really, really helpful in the robot, and I'll show you guys that in RViz. So let's launch the VM machine here, and I should have that come up. And let me take out the Intel system. So there we go. I got the RViz or the ROS running here. The password is car-user. I didn't see that. And I highly recommend installing the VAR file that they provided. It's like the ISO file. Instead of building all the dependencies and libraries independently, I ran into tons of problems over 3 days, and I was very, very frustrated. So I just imported this into 16.04 Melodic VM machine last night on VMbox and the virtual box, and it's working just fine. So once it comes up, we want to initialize a terminal. If there's not a terminal on the left-hand side, you can press Control-Alt-T, and it'll bring up a terminal. The first thing we need to do is one of the command line tools for ROS is ROS core. Okay, this is like the controller or the master. ROS will not work without ROS core. Okay, so you have to run this in your first terminal. I always run this in the first terminal. Once we get that up and running, we'll press Control-Alt-T, and we'll start a second terminal. Now we're gonna do the ROS launch command for right there, ROS car race car teleop launch. So here, I wanted to review this really quick because it's not explicitly kind of annotated within some of the instructions, but this little box here is actually the controller for RViz. So when you launch RViz up, and we're gonna ROS run RViz, and when that comes up, you use this little controller box, this thing on the side, to control the robot. Now we're not going to get there yet, but when we open the robot, let me minus this out. So we don't see the robot right now as it is because we haven't created a pose estimate. Now they asked you in class to import a pose estimate. I already had this saved, and then assign it to the sim car pose. Make sure that your global map positions say map at these background colors and frequencies. And then now we want to create a nav goal, which will be over here, right? I'm sorry, a 2D pose estimate. So there we go. So now we're going to start seeing that the car is right there, and if we want to drive it, right now I want to drive the car, I can't just click in that box in RViz. I have to click in the directional box here and use WASD to drive the vehicle. So on a reference vehicle, and a S is going to be back, W is going to be forward, and this is kind of cool, right? So now we're seeing information from the system from a node. The laser, you're seeing the laser scanner information, you're seeing some TF information, a transformation reference point on this exact point, X, Y equals 0, 0. So the robot knows where it's at in that space. But if I wanted to see a particular topic or nodes that are coming up, there's a few commands that we can use. So let's bring up ROS topic. Okay, ROS topic list, and this is going to give me all the individual topics coming from all the nodes and publishers and subscribers within the individual system. But I want to say ROS topic info \TF. So this should tell me, all right, that's my publisher. for that TF information, the transformational information, the quaternion to Euler angle algorithm, and it's going to say, okay, the SIMCAR pose is being sent by the publisher, the laser node is sending information out, but it's also a subscriber to its own information, so it's pulling it back in, right? And then the subscriber to the SIMCAR pose publisher is actually RViz. It's kind of cool. So you can see this information, and if you want to dial in like ROS node info, you could dial into that particular node and see all of the information that's coming back from it. Very advantageous when you're looking at the whole model of the system and understanding you know, the interdependencies of some of these systems. I also wanted to show you another one that I use. I'm not going to go into IDE or any of that yet. I'll do that. I'll save that for the next video. But you can say ROS node list, and there's going to be quite a bit here of individual nodes that are running, and this is probably going to be over there's a lot. So look at all the individual nodes that are sending pieces of information out. You got the laser node, you got the left and right wheel, the inertial measurement unit, but then you have all the Ackermann measurement messages. Now this is like a nodelet manager for the positional tracking and odometry. So there's quite a bit of information here, but I want to do a interdependency model graph of all the nodes and connectors in the system. So we'll do RQ2, and I believe that is graph. RQ2, I'm sorry, yeah, RQ2 underscore graph. There we go. So this might take a minute, but I also like this because this shows you all the connections between the systems, all the nodes and publishers and subscribers on top of the master and what it's doing within the system. Very, very, very helpful. And I hope this kind of illuminates a little bit for you guys to see what's going on within the system. But again, you can publish and subscribe to any individual node, and all that information is going to be within the system. Some of the command tools that we're looking at that we discussed before, I just want to review very quickly. Startup and process launch tools, ROS core, also ROS run. We did a ROS run, RViz. ROS launch is going to launch any one of those packages or dependencies. Then we also have ROS node ping. You can just say ROS node tab. It'll give you all the individual connections for that. And let me show you what that actually looks like. I always like to see examples. So ROS node and just tab. And this should bring up all the individual, there we go, perfect. So it has cleanup, info, kill, list, machine, ping. So if I wanted to ping an individual node to see if it was communicating efficiently or as we are expecting it to, then you could ROS node ping it here and its information and kind of go off from there. We also have, the parameter list. So ROS parameter list, ROS param list. Let me go back. Not ROS node. ROS param list. There we go. So these are all the individual parameters that we're pulling out, like the driver servo, max, min, and we go in to model some of these systems in PID, LQR. We're going to bring that information in from these things. Most of that stuff's probably already there. But hopefully this helps you guys a little bit, at least initialize this system. I'll create another video for IDE and creating subscribers and publishers, but also linking individual files together and how the system communicates as a whole as we get going. I hope you guys enjoyed this. Thank you so much, and I hope you have a wonderful Sunday.